Hello, welcome to our channel. In this video, we will talk about piecewise functions. So here is how we define piecewise functions. These are basically the functions that have different formulas in different parts of the domain. As a quick example, a piecewise function has graph like this one. Since it's defined differently in different parts of the domain, so for example, we can define it one way here, some other way here, and some other way over here. So this will have three pieces. So in the first interval, we may have a function like this one, a parabola. In the second interval, we may have a function like this one, maybe a sinusoidal curve. And in the third one, we may have a function like this one, maybe a linear function. So a function defined this way, we call it piecewise defined function. So let's look at more examples. So here is an example of piecewise defined function. So you see for x less than 0, we have the equation y equals x squared plus 2. For x between 0 and 3, including 0, not including 3, we have the equation y equals 2x minus 1. And for x greater than or equal to 3, we have the equation y equals 5. So to graph this, we look at these three pieces separately. The first piece for x less than 0, to the left of 0, we need to graph a parabola because y equals x squared plus 2 is a parabola. So in x is 0, y will be 2 over here, but we don't include this point at 0 because it says strictly less than 0. We have a hole here. And let's figure out one more point to graph this. When x is negative 1, it would be negative 1 squared plus 2, which is 3. So over here. So the graph will go like this. Something like this. So this is the graph of y equals x squared plus 2. And that is the first part of function f. In the second interval between 0 and 3, including 0 and not including 3, we have y equals 2x minus 1. When x is 0, y will be 2 times 0 minus 1, which is negative 1. And we include that point because x is greater than or equal to 0. So we include this point. Since it's a linear function, we just need one more point to be able to graph this accurately. So we can maybe look at x equals 3. At x equals 3, we have 2 times 3 minus 1, so 5. It should come up to here, but we don't include that point. So we have a hole here. Since it says strictly less than 3, then we can connect these 2 points by a straight line since it's a linear function. The graph will look something like this. Now the last part, for x greater than or equal to 3, the function is y equals 5, which is just a horizontal line at y equals 5. So we can draw that over here. Okay, so it will look like that. And we can include the point at x equals 3 because it says x greater than or equal to 3. So we can make that a solid dot. So this is the graph of function f. This is y equals 5. This is y equals 2x minus 1. So we just graphed f. So these three parts together make graph of function f. Now let's try to answer these. F of negative 2 would be, so from the graph, it looks like it's somewhere up here, f of negative 2. Let's also figure this out by looking at the given function, the formula for the function. So we need to decide which interval x equals negative 2 lies in. So negative 2 is less than 0. So x equals negative 2 is in this interval, x less than 0 because negative 2 is less than 0. So we need to consider this function, x squared plus 2. So this will be negative 2 squared plus 2, which is 6. So f of negative 2 equals 6. That we can see from the graph also. F of 0. Now 0 lies in the second interval because in the first interval, x is strictly less than 0. In the second interval, we start at 0. X is greater than or equal to 0. So 0 lies in that interval. That means we need to use this part for the second one. So 2 times 0 minus 1, which is -1. So f of 0 is -1. F of 1 also lies in that interval because it contains all real numbers between 0 and 3. So 1 is one of them. So we again need to use that second part of the function. So 2 times 1 minus 1, which is 1. So f of 1 is 1 over here. F of 3 lies on the third interval here. This one, because the third interval contains all real number greater than or equal to 3. So the function is y equals 5 for the third interval. So this will simply be 5. And f of 6 also lies in that interval. 6 is greater than or equal to 3. So f of 6 is 5. All right, so we are done with this example. Let's look at the next one now. Again, we want to graph this function. Here we have another piecewise defined function. So we again have 3 pieces. So the first one is for x less than -3. We have y equals -3x minus 10. So let's try to graph this quickly. When x is -3, y value will be -3 times -3, which is 9, minus 10 is -1. So the graph should go through that point. And we don't want to include this point because it says strictly less than -3. So we have a hole over here. And to graph this function, since this is a linear function, we need one more point. So maybe we can find the point when x is -5. So -3 times -5 is 15 minus 10 is 5. So when x is -5, we are at 5 up here. So the graph of this function looks like this one. So it's just a straight line connecting these 2 points. And so this is the graph of the first part, y equals -3x minus 10. Now the second part is y equals 2/3 x minus 4 between -3 and 3, including -3 and 3. So we can have solid dot at both of those points. So when x is -3, 2/3 times -3 is -2. So basically we have 2/3 times -3 minus 4. So this is -2 minus 4 is -6. So when x is -3, we have -6, which I assume is somewhere down here. It's like little outside the given graph. Let's pretend it's somewhere over here. And when x is 3, we have 2/3 times 3 minus 4. So 2/3 times 3 is 2, minus 4 is -2. So when x is 3, we are at -2, that point. So the graph of this function will simply be a line connecting those 2 points. Something like this one. We are done with the second part. The next part is for x greater than 3, strictly greater than 3. Again, we can try to figure out what y will be when x is 3. So here we have y equals 6x minus 20. So 6 times 3 minus 20, which is 18 minus 20, which is -2. So when x is 3, y is -2. It must go through this point. And to graph this, we need one more point. So let's find what y will be when x is 4. So when x is 4, we have 6 times 4 minus 20, which is 24 minus 20, which is 4. So when x is 4, y also must be 4. So it must go through that point. Again, this is a linear function. So the graph will simply be a line going through those 2 points. We are done graphing the function. So this last piece is y equals 6x minus 20. And this one is y equals 2/3x minus 4. So these 3 make the graph of function h. So next we want to figure out these values. So h of -5, again, we need to decide where that -5 is. Is -5 less than -3? Yes, it is. So -5 lies in this interval. So -5 is right here. So we need to use this function. So this will be -3 times -5 minus 10. So 15 minus 10, which is 5. So h of -5 is 5. H of 0 lies in the second interval here because 0 is between -3 and 3. So we use the second function here, 2/3 x minus 4. So it will be 2/3 0 minus 4, which will be negative 4. And that we can see over here also. When x is 0, y is negative 4. And each of 3 also lies in the second interval over here, because the third interval contains the values strictly greater than 3. So we need to use the second function again. So 2/3 times 3 minus 4. That will be 2 minus 4, which is negative 2. So each of 3 is negative 2. All right, so we are done with this example also, and this is all I have put together in this video. Thank you for watching. See you in our next videos.